All right, I'm going to make a quick video about solving systems using substitution method. So we're going to be able to solve the system of linear equations by substitution method and find the solution. So first we want to get our equations to either x equals or y equals. We only need one of them to get there. And then we're going to substitute that equation into the other equation. Then we're going to solve for the remaining variable. And then we can use that answer to substitute into the other equation. And then we're going to write our solution as an ordered pair. So let's look at this first one. We have 3x minus y equals 1, x minus 2y equals -8. I'm going to take this second equation and I'm going to solve for x. So x is going to equal positive 2y minus 8. So I'm going to move that 2y to the other side so I have one of my equations to be x equals. Now I'm going to take this equation, this x equals 2y minus 8, and I'm going to substitute in my first equation for x. So I'm going to write 3 parentheses 2y minus 8, close parentheses, minus y equals 1. So I'm going to take that second equation and substitute it for the x variable. And notice now we only have one variable, which is just y. So now let's solve for y. So I'm going to distribute. So after distributing, you should get 6y minus 24 minus y equals 1. Combine like terms on your left side to get 5y minus 24 is equal to 1. Now solve for y, solve for that variable. So we can do that by adding 24 to the other side. When you add 24 to the other side, you get 5y equals 25. Divide by 5, so our y variable is equal to 5. That is our first variable. Now we can use that and substitute back into that equation that we changed. X equals 2y minus 8. I can put this y in, substitute it into the y spot. So x equals 2 times 5 minus 8. So I can substitute that variable into the other equation. So I get x equals 2 times 5 minus 8, which gives me 10 minus 8, which is x equals 2. So I have my x variable now, and I have my y variable. So let's write our solution as an ordered pair, which is, remember, x comma y. So we have 2 comma 5, x comma y. All right, let's do example 2. And I'm going to pause you so you can work it out yourself and then check your answer. But first, we need to get one of our equations to either x equals or y equals. I see the first equation easier to get to be x equals. If I move 5y to the other side, I have x alone. So x equals negative 5y plus 1. So I'm going to take that equation and we're going to substitute it into x for the other equation. So when I do that, I should get negative 3 parentheses negative 5y plus 1 plus 4y equals 16. So we're going to substitute that negative 5y plus 1 into x. And again, you should only be left with one variable after substituting. Go ahead and pause the video, see if you can solve for y, and then plug into your other equation to see what your solution is. All right, did you get y equals 1? Perfect. Now let's take this y equals 1 and let's substitute it into the y for your equation that we got to be x equals. I'm going to go ahead and pause it again, try to solve for y, and then write your solution. Solve for x, then write your solution. Did you get x is equal to negative 4? If you did, that was correct. And then when you write your solution, negative 4 comma 1. All right, perfect. Let's move on. And we're not going to do all 4 of these next examples, but I do want to talk about for sure example 3 and example 5 because those are great ones to look at. So looking at example 3, again, your first goal is to get one of your equations to either x equals or y equals. I see this one, the second equation, easier to be y equals because I can move that negative x to the other side by adding. So I get x plus 3 on my other side. We can take this y equals x plus 3 and substitute it into the first equation for y. So I get negative 3x plus 3 parentheses x plus 3 close parentheses equals 4. Now my screen is lagging a little bit, so hopefully it will pop up very soon. I'm going to go ahead and pause real quick to see if we can get that to pop up. All right, there we go. We got negative 3x plus 3, but instead of y, we're substituting the x plus 3 equals 4. Again, now notice there's only x's in here, so let's solve for x. You're going to distribute to get rid of those parentheses. So when you distribute, you should get negative 3x plus 9 equals 4. Now let's combine those like terms. So we have negative 3x plus 3x. Notice those go away and you're left with 9 equals 4. Let's think about that. Does 9 equal 4? That is a false statement. So if you get something, excuse me, if you get a false statement like this, we know that that solution is going to be a no solution. Because again, 9 cannot equal 4. So we can stop there and say no solution. Let's go ahead and look at example 5. Notice, one of our equations is already x equals, so I don't have to rearrange it. I can just take what x is equal to and put it in x in my second equation. So I'm going to put 3y minus 3y equals 0. Now let's combine like terms. Oh, those cancel. 3y minus 3y is equal to 0, which 0 does equal 0. That is a true statement. So even though we canceled everything out, this is a true statement. So that means this solution is going to be your infinitely many solutions. So if you get a true statement, your answer is going to be infinitely many, whereas up here when we had a false statement, it was no solution. All right, I actually would like for you to try, if you were not here and you're looking back at the notes, go ahead and do examples 4 and 6, again, because those are great practice. I'm going to pause it, and then when you have tried both of them, unpause so you can see the solution. All right, here is the solution for example 4. We should have gotten 7, 6. Go ahead and look at the work. Pause if you need to. Sorry about that. Pause if you need to check your solution and check your work. Here is example 6. If you got a fraction for your x value, that is okay. It was negative 5 over 2, 9. Again, pause the screen to see if you need to check your work any. Double check your fractions and your fractional operations. And if you need to rewatch any part of this video, go ahead and rewatch.